Hello, and welcome to the Math 120 Final Exam Review for Doña Ana Community College. This is the grouping of quadratics. My name is Tuesday J. Johnson. I'm a lecturer at the University of Texas, El Paso, and an assistant professor at Doña Ana Community College. This is a series of videos where I talk about individual portions of the review. You can find the review for Math 120 at dacc.nmsu.edu/math, and in the right side menu you'll see all the you'll see a final review. Click on that, it'll take you to all the final reviews. The problem numbers in this video correspond directly with the problems on that copy of the review. Here we go. Alright, first of all, the no calculator logo, meaning your exam comes in two parts. The first part, you're not allowed the use of a calculator. The second part, you are. So in these videos, if you see the no calculator logo, it's on the first part of the exam. But these numbers are good. You shouldn't need a calculator. Let f of x equal to 2 times x minus 3 all squared minus 4. We're going to use this function. We're going to answer some questions. First of all, we want to know, does this graph open up or down? First of all, because it's degree 2, we know this graph is a parabola. This function is called a quadratic, and it's given to us in what's called vertex form. So, how do we know this parabola opens up or down? The a value of 2 is positive, and because that's positive, we know the graph opens up. Positive, people smile, the graph looks like a smile. What point is the vertex? Well, this is called vertex form because we can read the vertex right off of the function. Whatever we're subtracting on the inside, so x minus 3, I'm subtracting 3. 3 is going to be the x coordinate of the vertex. And the number as it's written on the outside of the square, the minus 4, is the y coordinate of the vertex. So we just pull those out. We could find the vertex in a very straightforward way. What is the equation of the axis of symmetry? Well, the axis of symmetry is a vertical line that goes through the vertex. All vertical lines are of the form x equals, and if it goes through the vertex, x has to be 3. So when you find the vertex, you already have the important information for your axis of symmetry. Axis of symmetry is a vertical equation, so it has to be x equals, and it always goes through the vertex, so you know the number value from the previous question. What point is the vertical intercept? Now we want our answer in point form. And vertical intercept. Think about the xy coordinate system. Which one is vertical? The y value is vertical. So to find the vertical intercept, I'm going to make an x value of 0. And I want to find the y that goes with it. So when x is 0, I put 0 in for x in my regular equation. 2 times 0 minus 3 squared minus 4. Using the order of operations, 0 minus 3 in our parentheses is negative 3. Use the exponent next. Negative 3 squared is 9. Now I'll have 2 times 9 minus 4. Continuing our order of operations, 2 times 9 is 18. 18 minus 4 is 14. So when x is 0, my y value is 14. I can label my vertical intercept as the point 0, 14. Now, what point is symmetric to the vertical intercept? Every symmetric point, when we're looking at y-intercept or vertical intercept, has a little formula to it. It's going to be the same height that we just found, because it has the same height as the vertical intercept, but it's always going to be twice the x value of the vertex. So if the vertex is 3 units away from the vertical intercept, then the symmetric point will be 6 units away from the vertical intercept, and so our answer is the point 6, 14. State the domain and range for f of x. The domain for every quadratic is all real numbers, negative infinity to infinity. Notice there are no denominators, no radicals, no logarithms, no funkiness going on at all, so we could use any x value, all real numbers. We decided the graph opens up. We decided the vertex is at 3, negative 4. which tells me that -4 is the lowest that the graph goes. I can hit -4, and then the graph continues up towards infinity. If it helps, you're more than welcome to draw this graph as you're going through it, but remember you're drawing it by hand, and you're kind of answering those questions as you draw the graph. Let's look at a second one of these. Let f of x equal -1/2 times the quantity x plus 2 all squared plus 3. We're going to use that function to answer each question. Now we know that because the a value is a -1/2, the a value being the coefficient of whatever's being squared, because it's negative, the graph opens down. Negative people frown, frowns go down. Stupid way to remember it, but it's effective. What point is the vertex? Well, what am I subtracting from x? It doesn't look like I'm subtracting anything. That's x plus 2. But remember that x plus 2 is the same as x minus a -2. And that's how I get my x coordinate of the vertex as -2. What am I subtracting from x? I'm subtracting -2. And that's why it's hidden and disguised as x plus 2. The y value of the vertex is the number out here, so it's a +3. The equation of the axis of symmetry, always a vertical line, so it's x equals, always goes through the vertex, so our number is given to us, in this case, as x equals -2. What point is the vertical intercept? Remember, just like the last problem, vertical intercept is a fancy way of saying the y-intercept. The y-intercept will always have an x value of 0, so I substitute an x value of 0 into my equation. Simplify, 0 plus 2 is 2. 2 squared is 4. Now I have a -1/2 times 4 plus the 3. Half of 4 is 2. Negative times a positive is negative, so I get a -2 plus 3 makes 1. I want my answer in point form, so x is 0, y is 1, my point is 0, 1. The point symmetric to the vertical intercept will always have the same height as the vertical intercept, but twice the x value of the vertex. If I double -2, I get -4 with the height of 1, my symmetric point. The domain and range for f of x. We know the domain of every quadratic is all real numbers, so in interval notation, -∞ to infinity. Now, we said the graph opens down. If the graph opens down, it has a high point. What's the high point? The highest it goes is the y value of 3. So our range, if we wanted to write it correctly, is -∞ to 3. Mistakes happen, people. That's why we review enough, so that when it comes exam time, we can minimize those. Sorry about that. All right, now we have a graph. And this is still a no calculator problem, but you don't need it. You already have the graph here. If I have this graph and I want to estimate f of 5. All right, here's 5, an x value, right? We normally have f of x. I replace the x with 5, so when x is 5, it looks like my y value is 2. When x is 5, y is 2, so I would write f of 5 is equal to 2. Part B, estimate the x values that make f of x equal to 1. What? I want to find the x values. Notice this f of x equals 1. What is f of x? That's just a fancy way of writing y. So I want y values of 1. Let's see if I could hit that. What x values make y 1? It looks like we're about, I have no idea, about 4.7, about 4.75 and about 9 1/4, 9 1/2 maybe. Close enough is good enough. It does say the word estimate, so I would estimate 4.5 and 9 1/2. I would not. I would stay on the correct problem. I would estimate as 4.75 and 9.25. Close enough is good enough. Estimate the horizontal intercepts for f of x. Record your answers as points. horizontal intercepts. Now that is where the graph crosses the horizontal axis. So I want to find where the graph crosses the horizontal axis. That looks like the 4.5 and 9.5, but notice I wrote them as points. When x is 4.5, my y value is 0. And when x is 9.5, my y value is 0. So I record them as points. State the domain and range. We know the domain for every quadratic is -infinity to infinity. Because this graph opens down, my range is -infinity all the way up to 6. And I use a square bracket on 6 because I can include that value. Alright, feel free to rewind. That's why I'm putting these on videos. Rewind, listen to it again if you need to. An outlet electronics store has calculated from past sales data the revenue from selling refurbished iPod Nanos. Fantastic, but it doesn't really tell us anything. The weekly revenue from selling these nanos can be modeled by R of n equals a -1.5 times n minus 60 all squared plus 5,700, where the R of n is the weekly revenue, that's why we use the revenue, from selling n iPod Nanos, and they are refurbished. N is the number of nanos. The output is the revenue in dollars. So what's the weekly revenue from selling 50 refurbished iPod Nanos? Well, there's 50 nanos. So put 50 in for n and simplify. 50 minus 60 using order of operations. Look at our parentheses first. That's -10. -10 squared is a positive 100. When I multiply a positive 100 times a -1.5, I'll have a -150. -150 plus 5,700 is $5,550. So if they sell 50 refurbished iPod Nanos in a week, they're going to make a revenue, an income of $5,550. Now, it doesn't take into account cost, but at least that's the money coming in. Find the maximum weekly revenue and how many refurbished iPod Nanos must be sold per week to make the maximum revenue. As soon as I see the word maximum, I'm going to go back up to this equation. Oh look, it's a quadratic, so we know it's a parabola. Because this first value is negative, we know it's a parabola that opens down. It does have a maximum. Its maximum is going to be at the vertex. All right, so maximum indicates vertex. What are we subtracting from the variable? We're subtracting 60. The number on the outside, the 5,700, the y value of the vertex. So what does this mean? When we sell 60 iPod Nanos, refurbished of course, you'll earn a weekly revenue, a maximum revenue of $5,700. So part B is just a fancy way of saying, hey, what's the vertex? And what does it mean in this situation? So if you can find the vertex maximum, make sure you use the information from what does each variable mean in order to put it together. One more, let's talk about veggies. The total fresh vegetables consumed per person per year can be modeled by V of t equals 0.7 times the quantity t minus 1.5 all squared plus 95.4, where V of t is the total fresh vegetables consumed per person in pounds per year, t years since 2000. That V, that's a mouthful. Find V of 6. I was just thinking that would have been a great example if it was V8, but we'll stick with what we have. Find V of 6 and explain its meaning. Round to the nearest integer. Alright, so first of all, let's find V of 6. V of 6, where there was a t, I'm replacing it with a 6. So where there was a t, I want to replace it with a 6. And I don't see any no calculator stuff here. I'll type that into my calculator, and I'll get 109.575. But what does it mean? Let's explain this. A t value of 6 is 6 years since 2000, so in 2006, each person consumed an average of, and I rounded it to 110 pounds of fresh vegetables. An average, all right, per person, so forth. All those words, all those words. Close enough, good enough. Find the minimum intake of fresh vegetables per person in pounds. Oh, find when. Let's read correctly. Reading is fundamental. And what the minimum intake amount was. Again, I see the word minimum. I go back, I'm like, hey, look at that. It's a quadratic. Because it's a quadratic with a positive leading coefficient, I know this graph opens up. If this graph opens up, my minimum will be down here at my vertex. What's the vertex? My vertex is 1.5, 95.4. So what does it mean? 1.5, 1.5 years since 2000. So I don't know, midway through 2001. A minimum of 95.4 pounds of fresh vegetables per person were consumed each year, that year. Oh, all those words. I simplified it. A minimum of 95.4 pounds of fresh vegetables were consumed per person. On average. That's it for the quadratics. That was a mouthful, I gotta tell you. There are other ones, other videos, so stay tuned for more. Thanks for listening.